There is a lot of concern about the rate of
prostate cancer
among the African American community, and it's proven by research that maybe 4 out of 5 cases that develops that sometimes leads to death actually happens among the African American community. And genetically, it's been noticed that this section of Americans are more prone to develop this. Now, a lot of information is being passed on as to why this is happening and how this could be, the incident could be prevented or handled when it happens. How do this happen? How do these incidents of prostate cancer happen? What are the causes? Do we cause it by ourselves, or is this a genetic thing that happens to Africans? And then now looking back from Africa, how prevalent is this in Africa? Do we do enough tests? We need to listen to what these experts are saying to know what we need to do too, to prevent this. When grandpa is not able to urinate normally anymore, what do we term this? If no tests are carried out, how do we know what the problem is? So this is a genetic thing, and if it happens in the African American community, if it's prevalent here, it means it's prevalent in Africa too, because they share the same genes. How can we do things that could maybe mutate or alter our DNA to make these things more prevalent? These are some of the information that are being provided by medical experts here. And the seminar is organized by Dr. Terry Mason, who is the chief name in this field with Cook County here, the medical director. We'll be able to hear more in a moment.
Well, the biggest risk factors are family history, of course age, family history, and race. And we know that African American men have a much more higher incidence and mortality. So black men are dying much more, larger numbers, almost 4-fold higher when you compare them to whites. So black men are dying. And still today, even though there's a debate about PSA, black men are still presenting, higher rates of black men are presenting with more advanced disease than whites, okay? And so these are things that I think we have to sort of really tease apart. Now when we talk about, a lot of the stuff that I'm gonna talk about and others are talking about, we're talking about numbers from publications, from research, and the bulk of that research, 95% of it, is on whites. And so when somebody says, well, we're over-treating, or we're doing, some of these men shouldn't have been treated, they're talking about studies looking at white men, okay? Family history, as I mentioned, is one of the biggest risk factors. And so knowing that family history is important, that means that genes are playing a role too, right? So what do we know about genes? Well, there's 2 sets of what we call these inherited genes. These are genes that we get from our parents, our mother and our father, right? And so there's 2 classes of those that are called risk genes. There's what we call the high effect and rare genes, and then there's the common low effect genes. So let me give you an example of the high effect genes. We've all heard of BRCA1 and 2 breast cancer mutations, where when you see that mutation, you see that change in the DNA, you see breast cancer. That's what we call high effect. But those are rare. Only, small number of families, small number of women carry those mutations, those changes in their DNA. But then there's a common genes or DNA changes that are like 30% in the population, 40%. And these have low effects. And so you need you need a lot of those to really see an effect in terms of risk for disease. So what did we found out looking at those 2 classes of risk genes? Well, we found very little of those high effect genes for prostate cancer. Most of the last 10 years, there's really just been one recent finding where there's a gene on, I think it's chromosome 17, where there's mutations in that are high penetrant or high effect. And they're very, very rare, maybe 1% of the population, so 1 out of 100 people may carry that mutation. And in some cases, it might even be 1 in 1,000. The common variants are those that we're concerned about, because if you have a lot of those common risk alleles, your risk would go up. Now, when we talk about family history again, I'm going to go back to family history. If you have like 1 to 2 or 3, or the number of increased relatives that have prostate cancer, it increases your risk. So some of us might have a 10-fold increased risk compared to the general population, because we have multiple family members, like father and brothers who had prostate cancer. And so we need to be clear that family history is playing a role. And that's one of the things that when you go to your physician, you should talk about. When you're debating if you should get a PSA test, or if you have elevated PSAs, if you're debating a biopsy, family history is something that's very, very important in that discussion. And a lot of times we don't know much about our family history, but that's something that I think we have to try to understand more and more. So genes are playing a role. So those are inherited genes that we get from our parents. But then, as the doc showed you on the board, we have the DNA in our cells, in our body, over our lifetime. And so from childhood, from birth actually, to when you die, your body is being exposed to different environmental, what we call carcinogens or stressors that can change the DNA in your body. So that's a different discussion than the inherited genes, the inherited DNA that you get from your parents. Those changes occur because we are exposed to certain things, like different environmental chemicals, or diet, or smoking, drinking. And all of those compounds have an effect in terms of changing the ability to change the DNA in our body. And in some cases it's in our colon, in other cases it's in our prostate or in our lung. And so we need to be clear. We know smoking is the #1 risk factor for cancer overall, right? Smoking is big. Drinking. But for prostate in particular, we know that there's some dietary factors that decrease risk and also increase risk, right? So what decreases risk? We know lycopenes in tomatoes, something I hate. We also know that some of the antioxidants in fruit and berries are protective against cancer, prostate cancer in particular. There's some emerging data now coming out recently on zinc and vitamin D as protecting, providing some level of protection against prostate cancer. But we have to be careful with that stuff, because a lot of these dietary substances, while at one level they may protect, at elevated levels they could increase risk. We see that with calcium, okay? Where recent data at selenium, where it shows that increased selenium, increased calcium, increases one's risk of prostate cancer. So it's like you can just run to CVS and grab some pills and gargle them down. You have to be very careful about that. And then also in relation to your diet too, we're talking about supplementation, but if you have a healthy diet, we're trying to get to the point where we have healthy diets, we don't need to supplement, right? What is that healthy diet? Well, and some of you are going to get very upset about this every time I say this, but increased red meat increases the risk for prostate cancer. And it's not just eating red meat, it's how it's cooked. And we, as African Americans, love to barbecue and burn our meat. I was just at a barbecue the other day, and they were burning some franks. They were fighting over a pan of burnt franks, and I was just looking at them like, these are burnt, y'all. It was adamant battle. But when you cook the red meat at elevated temperatures, you're releasing some, and you're creating some chemicals that causes DNA damage. Okay, and there have been really good studies looking at, not just in the prostate, but in the colon. Eating burnt red meat, whether it's char-broiled or grilled, it increases the risk for these chemicals, these what they call DNA adducts. They attach to the DNA and cause DNA damage.